Hello friends, welcome to my YouTube channel. Today I am going to discuss about threads in Linux. Basically the things that I will be discussing today is what is thread, how to create a thread in Unix or Linux platform, and there are various thread functions, other thread functions. What are the uses of other thread functions like thread join, thread edit, detach, all these threads functions, what are the uses? So all this I am going to discuss today. A little bit theory, then I will be showing a simple example here, how to create a thread and how to use various functions of thread. So let's start, friends, today's topic. So here, let's first understand what is a process and a thread. A process is basically a program in C language. Basically, when we call a main function, then it creates a process. So process basically is a program. So process can create its child process as well. In Unix or Linux platform, there is function called fork which can create a new process from an existing process. So this is how a child process can be created. But what is thread? Thread is a segment of a process, means a process can have multiple threads, and these multiple threads are contained within a process. So a thread basically is a part of a process. So if we want to do something without without halting the process, there we will be using a thread. So thread itself is a part of a process, but it has its own instance. So basically, if we will check a example, then I will be discussing about the memory part, how the thread is assigned. So let's first check a example how to create a thread, then we will go for rest of the discussion. So basically, to create a thread, we in Unix or Linux platform, this pthread create function is called. This pthread create function basically it has a thread ID, which is which is used to control this thread from the main process. So basically, once a thread is created, it is totally an independent thing inside the process. But from the main function, that thread is not accessible. But to access that thread, the thread ID is used. So this is the use of thread ID. Using the thread ID, you can call other functions to control the thread. So here is pthread attributes. This I will be discussing later. Various kinds of attributes are there of a thread. Using this pthread attribute, you can pass the attribute of a thread. So this I will be discussing at the end of this video. And here is the argument. Here is the routine. So basically, when you create a thread, you have to. I mean, what are the what you will execute inside a thread? These you will write inside a routine, inside a function. So that function will be. It will thread will create pthread create will create a separate instance of that function and run it individually in a separate memory. So this is the function of a routine. So here, word star argument. This argument basically is used for passing the data from the main process. So when you create a thread, there might be the use of a thread. You have to pass some data to initiate the thread. So that data you can pass as an argument in this parameter. So so pthread create has all these four parameters are there. So let's see an example first, then it will be very easy to understand. So friends, here is an example of pthread. Pthread is defined inside pthread.h function, h header file. So I have included the pthread h header file here. So rest of the things are normal. So so as I mentioned, pthread create. So basically, first let's understand why we need a thread. So you think an application where you have some. kind of some kind of work that you don't want your main process to hold. Like every night, 12 o'clock, you want to run some database job like purging or deleting this job. So at 12 o'clock, you will create a thread, and that thread will continuously run without halting the main process and delete the data from the database. So this is where the thread is required, where you want to run some, you want to do some work in your process without halting the main process. But you, so this case, you can create a thread and you use the thread to do the activity. So this is the use case of thread. So here I am showing you a simple example how thread will be used here. So let's see here. It's a it's a separate routine that I will be executing in thread process. So I have created a routine. This routine I will create a thread. So here I am not just doing one thing. I am passing a parameter here to this object. So the parameter that pthread function will call, pthread create will call, the argument will be passed as parameter here. So let's see here an example of pthread create. So here I have called pthread create. So as I mentioned in my so first argument is the thread ID. Second argument is the attributes. I am not passing the attributes here, so I kept it null. So third function is the routine. So routine is this. This is the routine name. So it will create a thread for this function. It will execute the whatever I have written here in thread. So and the fourth function is the parameter. So this parameter will be passed here. So here I have passed this parameter, and this parameter will be available here. So so what parameter I am passing? I can pass anything. I can pass character star. I can pass some character here. So here I have I am passing a structure here. So I have created a structure and I will pass a structure here. So let's see. This structure has two parameters, ID and name. So I will put that ID and name. So here in the main function, I have defined the pthread underscore t, that is used for thread ID. So the first parameter is pthread underscore t. So this is the thread ID. Second parameter is attribute, which I am not passing now. So third parameter is my subroutine name, and fourth parameter is is the data. So here I have defined the structure as a pointer, and I have allocated some memory. So when you pass it to a thread, you have to do it as a dynamic parameter, because static parameter you cannot pass to a thread because it's a separate instance. So you have to have the dynamic memory allocated for this pointer, and you can pass this pointer as a void star object. Then you can typecast it to your own data type. So here I have passed the pointer. So here I have typecast this void object to its own format, own data type. So here when I have so here is a small example. So here data one I have defined. So data one value, ID value, I have put 10, and put some name as thread one. So I will be showing multiple threads. So let's first see the thread one. So after creating pthread create, it will create a thread. So let's see this example first. So to compile this function, I have to run this. So pthread.h is the header file, and leave pthread is the thread library is. I will define the library like this for compilation purposes. So hyphen L pthread. This is the thread library, pthread library. So I am compiling this. So it generated one a.out file. So let's run this a.out file. So friends, here you see it got exited. So the reason is that it created the thread, but I just got exited from the main function, so it got exited. So to keep it, I have to run a while loop here, so that it will keep running the thread. So I am compiling it again. So friends, now I have halt it in the main function. I am holding it for some time. So the you can see that I am printing the inside the thread. I have printed the ID and the thread ID, thread name. So so here I have passed ID as 10 and name as thread 1. So which I am printing here, which I am printing here. So so the thread got created successfully. So this is a small example of how to create a thread. Now let's see the more in details. So here we have created a thread successfully. So in Unix or Linux, when you do PS, PS function is used for getting the threads. So how many processes are running? So here, whenever any process created, you will get a thread ID, process ID created, which is called PID. So here you can see that in my system so many processes are running. So this process, every process has its own process ID. So when I will create my test function also, it will have its own process ID. So it creates a process, but the thread I cannot see it separately because thread is a part of that process. So let's see how the memory allocation for a thread is done. So here you know when you create a process, process has its own stack memory, heap memory, all these are there. But when you call a pthread function, pthread create function and call a routine, so that routine also in normal, if you call without pthread create, if you call a normal routine, it has its own stack. So here, when you call a routine with pthread create, it creates its own memory area where it allocates its own stack and register. So how many times you will call pthread create? Every time it will create its own memory area. So this memory is not accessible from this, though it's a part of this process, but this memory is directly not accessible from the process main function. So these are individual threads, but we can access this thread or control this thread from the main function with various other functions. There are so many other functions are created which can communicate with these threads. So here I have shown you that pthread underscore t. This is the thread ID. Whenever you create when you call a function pthread create, it assigns a thread ID here. So this thread ID we can use in other functions to control the threads. So let's see the other functions. What are the other functions? Let's see. Okay, so before going to discuss about other function, let's see the program a little bit more. So let me. So I have created one thread here. So let's create two threads with the same routine name. So here I am creating the same pthread underscore print underscore thread routine with two different set of data. So you can see here I am passing 10, here I am passing argument as 20. So this will create a two thread 1 and thread 2. There will be two different instances of thread will get created. So every time I will create call this pthread create function, it will create a new instance. So this instance will run parallelly without halting the main process. So main process will execute its things like you can see here. Main process is printing main function, and here it will print its thread will print its thread related function. So here 10 and 20 I am passing, so it will print separately 10 and 20 and without halting the main process. So let's recompile it. So you see that 10 is printing. So these threads are individually running. So one time is, I mean, the CPU scheduler assigns some time slots to these threads. Whenever time slots happens, it will print its every time slot. It will call the threads and it will print that corresponding thread. So you can see that now two threads are created, one thread 1 and thread 2, and the arguments that I am passing separately 10 and 20, these are getting printed separately. So this is how multiple thread works. Now see now I want to check other functions like pthread join. What is the use of this pthread join? So previously when I was not running this while loop inside the main function, the thread got exited. So to keep the so in the main function, if you want the thread main function shall exit only when the thread is completed. This case you can call the pthread join function. So this is the use of join function. If you join this, if you make it a join thread, in that case the main function will not exit until the thread got exited. So I will show you this example. So let's see the other functions as well. Pthread equal function, which is used for comparing the two threads are equal or not. So basically, when you call pthread create, it will create the thread ID. So you have to pass. Say you created two different threads. You have to pass the thread IDs here to check whether the two threads are equal or not. So another function is called pthread detach. This pthread detach function is basically used for the resource uses. Now when you run a bigger program which where you will create the threads and destroy the threads continuously, there are uses like when you are doing something on thread, you will create, then you will release the thread. So these cases, if you continuously do this kind of stuff, the resource every time whenever thread is created, it creates its own register, it creates its own stack. So when it releases those memory as well. So so every time you don't want this, if you do all these kind of things continuously, your system will go out of resource. And you can see if you run it continuously, you can see that one time you will fail to create the thread and you will get out of resource thread error. So these kind of issues you can resolve by calling pthread detach with the thread id. After creating the thread, you can call pthread detach with the thread id. So whenever that thread will release, it will not release its resources. It will just give these resources to the memory and for reuse. So next time when the same thread will get created, it will reuse the thread. So reuse that resources. So that is why pthread detach is used. So we always create detach thread whenever this thread is continuously in use and release. So every time we'll create, it will get the detail, it will get the resources from the already used resource. So it will never go out of resource. So another is pthread cancel. So pthread cancel is used to cancel a thread from the main function. So I will show you an example here how pthread cancel works. So here, let's say I am running 10 loops. Let's say when 5 loop will run, I will cancel the thread 1. So here you can see that I am passing the cancel thread 1. So thread 1 is my first thread ID. So I will call this cancel function to cancel after 5 iteration. So let's see. Thread 1 value I am sending 10. Thread 2 value I am sending 20. So after 5 iteration I will stop this. So let's start it. So 20, 10 both are running. 20, 10 both are running. So see, now only 20 is running because after 5 iteration I have stopped this 10. So let's see, let's make it more, then you will understand. Make it 20. So after 5 iteration, now you can see that I have already cancelled thread 10. First thread I already cancelled, so that thread already stopped. So now only thread 2 is running. So this is how I can control it from the main function. So this is how you have control over your main function, over your thread from the main function. Now we know that pthread join is used for joining thread. So until the thread will stop, uh, main function will not release. Let's make small change inside the thread function. Okay, before doing this change, let's block this while loop completely. So previously when while was not running, the main process got exited. So now I will create a now I am creating a join thread. So thread 1 and thread 2 both are join thread. So until this thread 1 and thread 2 will exit, the things will continuously run. So this is the use of pthread join function. So let's see. So now you see that the threads are not getting exited. So this will continuously run because I am running this in while loop. Uh, so this will never exit basically. So because my threads are not exiting, so I will make a small change in the thread so the threads shall get exited. So you can see here I am just keeping a count here. So if so whatever ID I am passing, if I equal to this ID, then it shall come out from the while loop. So first thread will come out after 10 iterations, and second thread will come out after 20 iterations, and after that the main function will exit, as these are all join threads. Let's compile it. Okay. So let's wait for 20 iterations. After 10 iterations, first thread will exit. So you can see here. that first thread already exited, but my main didn't exit yet because I have created both the threads as join threads. So once the second thread will exit, then the whole thread will get exited. Whole, I mean, main will get exited. So see here, after 20 iterations, the second thread got exited. So my main also exited after that because here I have called the pthread join. So thread 1 and thread 2 both are joined. So once both the threads got exited, the main got exited. So this is how these functions works. Thread cancel, thread join. So here I already called the detach function. Here pthread detach function I have already called. So then whenever thread 1 will get released, it resources will be reused by the memory. So these are the use cases. So let's see, one more function is there, pthread exit. So this pthread exit is called inside the thread itself to exit from the thread. So another use case of pthread exit is that here you can put some characters when what are the reasons for pthread exit, and this pthread exit can be read here as well. Uh, After exit, pthread join has its own second attribute is there. That whatever you will return in pthread exit, you can read it here. You can read the text here or error here. So whatever reasons the thread exited, you can print it here. So this is the use of pthread exit. Okay, friends, now see the pthread attributes. So pthread attributes are basically the attributes that are used for controlling the thread. There are various properties of the thread that you can change. The default properties of the threads you can change. Like you can read the properties, you can write the properties. Like thread concurrency level, you can read and write those concurrency levels. So here is an example, like stack size, but the in OS it has some stack size. Default stack size is there. If you want to change the stack size, you can use the attributes function to change the stack size, and you can pass these attributes to the thread while creating the threads. So let's see an example here. As I mentioned, the second parameter is the attribute parameter. So how to pass this attribute parameter? Let's see the example here. So so pthread attribute underscore t. This object is there. So you can create an attribute object here. So this attribute object you have to initialize first. Pthread attribute init function is there to initialize this attribute. Then you can use the get stack size, set stack size. All this you can do. Stack size, and ultimately you can pass this attribute parameter here to impact to apply those change properties on specific thread. So this is how the thread attribute works. So I will be showing you a separate video. I will be uploading another video related to attributes only, because there are lots of attributes you can change, you can put in thread functions. So I will be showing those attributes separately, but it's just a small example where you can how to apply the attributes. So pthread attribute init is used for initializing the attribute. Then you can call specific get function to get that attribute and set function to set that attribute. And while creating the thread, you can whatever thread attributes you will set, you will pass this attribute here. So those changes will get applied to that on that thread. So friends, this is all about threads. So these are all thread functions and how thread is used. So thanks for watching, friends. So before before completing, so here I have my own channel here. So here I have uploaded more videos related to C, C++ in Unix Linux platform. So I will be so here you can see other videos related to C, C++, and you will find more interesting videos on C, VoIP and various telecom protocols. So you might be interesting to see the SMS and WebRTC SMS how it works. So you can check all these videos if you are interested. So here friends, you can subscribe to my channel to get latest updates here. So you will get a notification here if you are subscribed, and I will upload a new video related to these things. So friends, thanks for watching. Don't forget to subscribe and share if you like this video. Thanks friends, thanks for watching.